Before we get into the laws of logarithms, let's just make sure we understand what logarithms really are in general. Everybody figured that out yet? What? I mean, what is a logarithm? I assume most of you haven't figured that out yet. I just wanted to know if anybody has. Just something simple. It's just a different way of writing exponents, right? So last week we talked about changing this into an exponential function. The base raised to that answer equals x. Okay, so rewriting or transforming a logarithm into an exponential function. So if we have all this up here, these bases and these answers, then we can understand that the log of base 2 of 8 is really 3. If we transform that, it's 2 to the third equals 8. So it's just a different way of writing exponents. Fancy way of writing it. And it gets more complex than that, but that's basically what we're dealing with. So having to write exponents in different ways. And then you got some properties last week that you used, and today you're going to get to things called laws. So let's start with the first one. Log of base A of A times B is the same thing as log base A of A plus log base A of B. Anytime you have multiplication, you can split it apart into addition. So let's just do something very simple. We just did log of 8 on base 2. I could say that's log base 2 of 2 times 4. Can't I? Isn't that the same thing? Okay, so I'm just using some basic numbers to show you that it does work. Alright, so if we split this multiplication apart, log base 2 of 2 plus log base 2 of 4. What is this right here? You learned that last week. What is that answer? Remember? 1. And so just for those of you who've forgotten, 2 raised to the y equals 2. So what does y have to be? Y has to be 1. So anytime you have these being the same as the exponents, that's 1. Here, last week you were taught that you need to make these two the same. So that 4 is the same as 2 squared, what we have right here. So what is that answer? 2. Okay, that answer is 2. And 1 plus 2 is?
3.
3. And isn't that what we said log of base 2 of 8 is? The answer is 3. Okay. So that's just using some simple bases and numbers to show you that this does work. So you can split apart multiplication. Alright, that's the first law. Law. Okay, second law. Log of A divided by B. What do you think that's going to be? Subtraction. So it would be log base A of A minus log base A of B. And we use the same type of thing over here. If we do, we'll do log base 2 of 16 over 2. Okay. So we know that the answer is 3. Log base 2 of 8 is 3. Okay? Am I going too fast? Yes? Well, it helps if you attend school regularly. What? I was giving you a hard time. I'll slow down. But I am covering some of the things in this, so. Did you guys watch the video? No.
The homework is.
I'm giving you an opportunity. Good. Alright, we good? Does everybody understand what I've done here? Just picking values that we know the answers to. Log of base 2 of 8 is 3. Alright, so our answer should be 3 when we're done. So if we split these apart, log base 2 of 16 minus log base 2 of 2, top over the bottom one, top minus the bottom one. Okay, again, last week you had to make this a 2. So 2 at 16, we're going to use 2 to the 4th. Alright, so what is this answer? 4. And what is this answer? 3. That's what we said it was. Obviously we're going to get through some very complex forms, but really it's not much more difficult than this. Alright, so those are the two laws. We have one more law. So these 3 laws are on the quiz tomorrow. Log base A of A raised to the C power. Is the same thing as putting the exponent out in front. So again, these are just manipulating the way a logarithm looks, just like we manipulated trinomials into, we factored them so they look a little bit differently. In algebra, you learn how to manipulate a whole bunch of different equations just by moving things across equal signs. Here's 3 different ways of manipulating logarithms, along with the identities, the properties you used last week. Alright, so if we just do this same thing, log 2 of 2 to the 3rd. Okay, so we know that answer's 3. But I'm just showing you, if you take the exponent and put it out in front, what is that? Log base 2 of 2.
1.
So you have 3 times 1, which is 3. Alright, so we used a basic logarithm to help show that the laws do work. Obviously those are not proofs that they work, we're just showing you that they do work. Those are the 3 laws. 3 laws. They are the first 3 questions on the quiz tomorrow. They're also on the test. Okay. Alright, excellent. Let's do some problems. Must have been a long weekend. Every class has been quiet. Okay, let's do number 8. Log base 2 of 160 minus log base 2 of 5. Okay, the whole point here is working one of the laws backwards. So which one is this? Subtraction, so what do? Division. So the log base 2 of 160 over 5. What is 160 divided by 5? Write it down, take your time. What is it? 32. Okay. So now you have what you were doing last week. Everybody change it for me and tell me what the answer is. Let's see. Yeah, now tell me what the answer is. Log base 2. You got to make the 32 a 2 somehow with an exponent. Hard to pass. It is possible, but it is hard to pass without notes. Hard to pass without participation. No? Let's get it. Don't understand. What's 2 raised to what power is 32?
5.
So that whole answer is 5. raise your hand if you don't understand why it's 5. Okay. Next, let's do 10. We'll just kind of do a bunch of these for practice. Log of 1 over the square root of 1,000. Now you're going to split it apart, expand it for me. So it's division. What are we going to do? Subtract top minus bottom. So the log of 1 minus the log of the square root of 1,000. Log of 1 is on the test. That's one of the properties you learned last week. What's the log of 1? 0. If you don't understand that, look back, go back in minutes. That's 0. Now, we don't like radicals, considering what the last two classes were like. I'll go ahead and re-explain this. The nth root of a to the m is the same thing as the nth root of a raised to the m. Okay, so this can be written as a to the n over n. M over n, these. Both of those can be written that way. It doesn't matter if the exponent's on the inside or on the outside. It is the top number in the fraction of your exponent. Alright, whenever there is not a number written here, then it's always a 2 for square root. And this has an exponent of 1. So this is going to be the log of 1,000 to the 1/2. Again, one of the laws, I can put this on the outside. So I have 0 minus 1/2 times the log of 1,000. Now what do you know about base 10 and 1,000? Base 10 and 1,000, what do you know? 10 to the first is 10, 10 squared is 100, 10 cubed. Okay, so what is that? What's 1/2 times 3?
3 halves.
3 halves, so 0 minus 3 halves is negative 3 halves. So again, whenever you see this stuff, you have to convert these so the bases match. Now as you go through your homework tonight, we're going to get to the point where we're just manipulating. You won't be able to solve it. At the beginning part of your homework, you can solve it and get answers. But we're eventually going to get to the point where we're putting letters in and you're just showing that you know how to expand it or you know how to put things back together. Okay, make sure you understand this. It's all algebra. Next, let's do, let's just keep going. Example 12. Log base 12 of 9 plus log base 12 of 16. Begin. Let's see if you can do it. Taylor? Tell me how to do it.
Yeah, I got you.
What? What'd you get? So addition means you're going to multiply. These two need to be the same if we're going to solve it. 144 is 12 squared, so the answer is 2. Good job. Alright, so let's
I'm just confused on how you know when to do what. Like, why are we multiplying?
okay, so when there's addition between like logarithms, meaning they have the same basis. Addition or subtraction, that means you're either going to multiply or you're going to divide. So if it's addition, you're going to multiply. If you condense them, you put them together. If you have multiplication and you want to expand it, then you're going to show it as addition. The whole point is that you can manipulate the way it looks and possibly be able to come up with an answer without having to go grab your graphing calculator and try to figure all that stuff out, because this is obviously something you could do in your head. Okay, or at least write it down and figure it
It looks like a dumb one.
out. Okay, but it's just teaching you different ways to manipulate numbers. That's really all you've been doing so far. In the next chapter, we deal with trigonometry, sine, cosine, tangent, and it gets kind of complex. But again, it's just a different way of doing angles and triangles and calculating distances and a whole bunch of different things. It's very applicable to real life situations, which 95% of you are not going to ever use unless you go on and do really important stuff. Not that working at Walmart is not important. Many people at Walmart, but you're probably not going to use trigonometry at Walmart, right? Yes? No? Okay. All right. So let's do some more problems. How about we make it really difficult?
All right.
The very next one is difficult. And we're only on 14. Let's see if you can do this. Log base 3 of 100 minus log base 3 of 18 minus log base 3 of 50. Just do it in order, left to right. Let's go. Work it left to right and do it in order.
Come on.
Yep.
What? Says what? This scares my feelings.
All right. I'll help you out to start.
I'm sorry.
We got that far. Give you all right. We're progressing. By the end of class, hopefully all of you will get it. Got lots to do. Quizzes first thing in the morning for the other classes. First thing when the bell rings for you guys, I'll check your homework after the quiz tomorrow. You'll have 5 minutes to do the quiz. You'll need about 2 minutes. Okay. All right. So now we have a complex fraction, 100 over 18 divided by 50. How do you get rid of a fraction instead of a fraction? Cry. Cry doesn't get it done, and it just makes you feel worse. No, it makes you feel better? Cry.
Mine makes you feel better.
Divide 50 by 100 and get 2 divided by 2 by 18.
Take 100 over 18 and multiply it by the reciprocal of 50. Alright, those reduce. You can also reduce the 2 over 18. So what do we end up with? Log base 3 of 1/9. Everybody knows what that is. You gotta get the 9 and the 3 to be the same, so what are you gonna do? Right? 3 squared is 9, isn't it? Okay, but it's in the denominator. How do I move it to the numerator?
Negative exponent.
What?
If you use a negative exponent.
Yeah, we change the exponent's value. So that's 3 to the negative 2, so the answer is negative 2. So all those logarithms give you a negative answer. Okay. so there's a lot of work. Ready to make it ugly? Oh no. Oh no. No, they don't get worse. They don't necessarily get worse than that. It's just they're just different ugly. There's ugly and then there's different types of ugly. Okay, let's do this one. How about 18? Natural log of the natural log of e raised to the e raised to the 200. That's ugly. No. One of the laws that you have is exponents. Now you should know what this answer is if you just think through a couple steps. But we'll go ahead and work it out. There's two different ways you can work it out, but we'll just pick one and go with it. You have this raised to an exponent. What's the law of the exponents? What's the new law you learned? Put the exponent, this is an exponent, in front. So it would be natural log of e to the 200 times natural log of e. Well, if you remember, the natural log is just the log of base e. So to refresh your memory. So what is that answer? 200. And what is that answer? 1. 200. Wasn't too bad, was it? Now you could have noticed that this was the same, and so this answer was just e to the 200. And the natural log of e to the 200 is 200. It doesn't matter how you do it, you get the same answer. Alright, so that was kind of ugly. Alright, so here you don't get an answer, I just want you to tell me what it is. Let's do the log base 6 of the square root of 17. I want you to rewrite it, manipulate it, change it. Real simple. I'm sorry, it's the fourth root. Fourth root of 17. Just change the way it looks, please. So you got to get rid of your radical. I wish I could get that to click with you. Wish I could get inside your head and just go.
You do.
Just kidding. I do that every day, don't I?
Yeah.
Okay, so how do I manipulate the radical?
17 to the 1/4.
Yeah. This is just 17 to the 1 over 4. And then that's an exponent. So I would write it on the outside, 1/4 times log base 6 of 17. That's the answer.
Yeah, that's not bad at all.
It's not bad.
Just wait for it.
Alright, and then we turn the page over. Let's do 28. Let's see if you figured this out yet. Log base 2 of xy to the 10th. Two things, two of the laws that you're going to use to manipulate this. Two of the laws. What do you think you're going to do first?
The exponent on the outside.
Let's get rid of the exponent. Let's put the 10 in the front. But the key here is that you understand that it's 10 times all of this. So if you do not use your brackets and your parentheses correctly, you miss the whole problem. So you understand that the 10 is on the outside of this parentheses. That's very important. So what you do from here on out better look like this. This is 10 times everything that's inside that. Now, what do you want to do? What do you have? Multiplication, addition, subtraction, division? Which of those four do you have? Well, what's up here?
Multiplication.
Which means you're going to, yeah. And that's that problem. Now technically you can put the 10 on both of those, but I'd rather you just do it like this. Alright. Alright, let's see. Let me just give you another one, and we'll see who's going to get the right answer. How many we got? We should be getting a few more of you catching on. Let's do 30. And then we got to talk about change of base. X squared over y times z cubed. Expand that, please, on base A. Just do one thing at a time. Don't make it up. Don't make your own rules up. What do you want to start with?
Separate it.
Good. Alright. See how everybody's starting it. You started? Okay. Not sure what to do. Okay. Is it a fraction? What do you do with fractions? Subtraction.
Oh, okay.
Subtraction. And then you have a whole bunch of exponents. You also have a multiplication in your denominator. So you should start by getting rid of the fraction. That's the first step. Alright, let's see how we go from there. Take a chance, try something.
Wait, is that the final answer?
No.
That's the next step. Yeah, and that's the step after
Except that would be right, except that is only on the z. That should go right there. And you're right for the parentheses. Alright, so now you don't have to have those parentheses there, but it is a group. This right here is a group because of that. So you should have this group together when you split it apart. That 2 goes out in front, minus. Now we separate multiplication with addition. That 3 is only on the z, it's not on the y, so it only goes in front of this part. And that would be the correct answer. Did you get that? Or were you close? Close. Close, I'll get you half.
We're fishing in the right pond, just not catching the good
Gotta have it all.
fish.
Okay. Let's do change of base, and then I'll give you another one of these. Alright, so this is called change of base. Let's say we don't like our base. This is number 52. Oh, no, 56, sorry. Log base 5 of 2. I want to know what that equals. Most of you don't have calculators, they're going to change the base. So I'll show you how to do it. It's very, very simple. Change it to a log of base 10. That number over the base 10 of the base. That's all you got to do. Change my bases to 10s. That number over that number. and you put it in your calculator and you actually figure it out. Log of 2 divided by log of 5. Most basic calculators, the scientific calculators we have log buttons. You have a log button on your calculator. If you want to put it in there, you get 0.301 for the top, 0.699 for the bottom, which would be 0.4307. That's not on the quiz. I may ask you to manipulate it with change of base. I'm not letting you use calculator on the quiz, so you may have to get it to here. So don't forget how to do that. There's a few of these problems in your homework, not very many. Let's do another one. Let's see if you can get this one. 58, log base 6 of 92. Change your base to log base 10. And let me just check to see what you have just for the manipulation. And then you can use your calculators to figure it out. Just mirror what we did on the other one. Yeah. You don't have to write base 10.
Okay.
It's understood that it's 10. Then you would just use your calculators to figure it out. That's correct. Good. You good? Figure it out? Good. Awesome. See, you got it.
Yeah, you're awesome.
So this would be log 92 base 10 and log 6 base 10. And those of you who use your calculator, I got 2.5237. Okay? Alright, let me give you the assignment and then I'm going to do a couple more on the board. Okay? Page 329, 7 to 61 odds.
You want me to record the next problems?
I'm just going to